Hello my dear students, welcome to all of you in our PPS video lecture series, and our second unit is already started, and the topics operator, operator precedence, associativity, type conversion, these all the topics we have already covered in our previous lectures, and now today we will cover the next topic, that is execution of C program. It is already done in our practical sessions, how we can execute it. So the first step is system ready or not. System means our laptop, our desktop, that is in a working condition or a not. Suppose it is in a working condition, then we have to enter our program, that is our software for making C program. That is very different software available like TC, Dev C++ or Notepad++. Here in our PPS we are using Dev C++ software. So first install that if there is no any software for making program, and after that we have to edit our program, or we can type our program and in that particular software, that is edit source program. After editing, now we have to compile it for checking the errors. Now there are three different types of errors. First is a syntax error, second is a data error, and third is a logic error. So what is the meaning of it? First, about the syntax error is what? Suppose you are missing semicolon at the end of each and every statements in a void main, then it is known as syntax error. Suppose you are writing wrong spelling for a printf or for a scanf, then it is known as syntax error. Now data error means what? Here suppose in your program you are writing data type integer, and at the run time you are entering float value or a character value, then it is considered as a data error. And third is a logic error. Means suppose I have given one problem like perform addition of two numbers, and in this example you have to put just plus sign, but by mistake you are putting multiplications, then your logic is wrong. So in that type of, we can say that the logical error is there. So this type of errors will be checked by compiler? No. When we are compiling our program, it just check about the syntax error, and if the syntax error is there, then simply we have to move to the part that is edit source program and make the changes. But there is no any syntax error, then we have to directly move to link with a system library, and system library is nothing but our header files that will be linked in our program. After linking, we have to execute our program, and for that we have to input the data. For example, addition of two numbers, then you have to input two values, that is nothing but our input data. Now when you are entering data, there is a two possibility, you are facing data error or a logic error. So if there is a data error, suppose you are typing integer in your declaration part, and here at the run time you are just input in a alphabets or a float value, then what happen? It is known as a data error. In this case you have to again input the data and simply execute it. But suppose you have another error like logic error, then you have to make the changes in a program. So first you have to move to the edit program, make the change that is required for the particular logic, and again compile and run the program. So if there is no any data or a logic error in your program, then and then you have finding correct output. So this is the flow how our actual program will be executed. So now next we will see the practical sessions for a different operators and regarding this theory. The Dev C++ software here I am using for our practical, and today we will learn about the practically how we can apply the different operators. And first operator is arithmetic operator that we have already discussed. So plus, minus, multiplication, division, this concept you guys understands, but today we will learn about more modulo operators, and for that we are taking two different variables. First is an integer a equals suppose 9 and b equals 2, and answer is stored in a variable c. So modular operation is used for what? Finding the remainder. And 9 by 2, if you perform 9 by 2, then the answer is 4 or 1. The answer remainder is 1, but the division operation perform 4. Clear? So two different variable I am taking, c for a division and d for a modulo. So first we are writing c equals nothing but a divided by b, that gives the answer 4, and d equals a modulo by b, that finds the remainder of a and b, that is 1. And now we have to print these two values, and we are using here the printf functions. In printf we have to write just like division equals percentage d, and then we have to print the value of c. After that we have to again print the another value, that is remainder. So remainder equals percentage d again, and the value of which we have to put the variable d. Now execute this program. For that first we have to compile it. So in a execute you can see here the shortcut, that is F9. So here the error is 00 and warning is again 00. So you can run your program. Here the output is what? Division equals 4 and remainder equals 1. So I hope you guys understand these two operators, division and remainder. Now move to the second type of operator, that is a relational operators. Now relational operators are different operators like greater than, less than, greater than equal, less than equals, double equal and not equal. So here I am taking the simple example to check both the numbers are same or not, and two variables, integer a equals 10 and b equals 2. Now we have to check condition, and for that we have to apply if and else. So first write the if, and inside if we have to write condition, that is a equal b or a not. If it is equal, then our answer is what? Printf both are same, both are same. And if this condition is false, then we have to jump on a else part, and in a else we have to write printf both are not same. So I think you understand this equal to sign. If you put just a signal equal to, then it becomes an assignment operator and your output is incorrect. So this type of mistake we can say that logic errors, but here we are putting double equal to for a checking both the numbers are same or not. So just run this program, first compile it, there is no error, so run this program, and the output is both are not same because a is 10 and b is 2. Now simply change the value of a, and that is 2. So here our if part becomes true because a is 2 and b is true. So our condition becomes true and the answer we will find both are same. So again compile the program, 0 error, execute it, and it just display the answer, that is both are same. So this is about the relational operator. Now move to the next operator, that is the increment and decrement. Now here for increment and decrement operator is categorized into two, pre-increment and post-increment. So first we are taking one simple a equals 10 variables and two variables b and c is for a output. So simply I am putting like b equals a plus plus. Then what happen? it is known as post increment because the operand is first and then our operator is there. So in this case what happened, the A value is assigned to B and B becomes 10, and after that the A value will be incremented. So what is the output of this program? First print it, printf. In a printf we are printing both the values. First A value, that is %d, and comma the value of A. After that we have to print same for a B equals %d and then comma the value of B. So what is the output? A is incremented, that is 11, but B is same 10 because here we are using post increment. That concept you have to remember. So run this program, execute it. There is no error, so you can directly run your program by F10, and our output you can see here, A equals 11 and B equals 10. That is already discussed. Now change here, instead of A plus plus, now we are putting plus plus A. Then what happened? It is now converted into pre-increment, and pre-increment means both the values are changed. Why? Because the operator is before the operand. So the original value is also incremented and then that updated value will be assigned to the variable B. So in this case you can see the output here, put just /n, so you can find the two different values /n here and execute this. So there is no error. Run this program and you can see the both the values are 11. A is also incremented and B is also incremented. So hope you guys understand this concept, increment decrement, very well. Now move to the next operator, that is bitwise operator. The bitwise operators are mainly different like simple AND you can do, or you can do exclusive OR, and the shift left and shift right. Here I am taking just the example for a shift left how it is executed and shift right how it is executed. For that, first declare the variable A equals 4 and our answer is stored in a variable B. Now how we can write? For that you have to write B equals A less than 1. What is the meaning of it? Less than, that is a shift left operator. So it moves the value of A in a left position by 1 bit. So first A value is how executed? It is converted into binary value and then 1 bit only it is shifted left side. So we have to print this that value of B. We are writing printf shift left, that is in a B. So B equals %d and the value of B that we have to print. So what happened? Let's see here, compile that program, there is no error, execute directly and the output is B equals 8. So here you can say that whenever you are applying shift left concept, then your original value is incremented. Here A is 4 and when you are moving it in a left side, then it becomes more, that is here in this case it becomes 8. And when you are applying another operator, instead of less than, suppose you are applying greater than, then meaning is changed. Now it is a shift right side. What happened? Let's see here, by executing this program. Here you see the value B equals 2. So the A is 4 and that is decremented whenever you are applying the operator shift right. Clear? So these all are about the bitwise operator. Now move to the size of operator. Now if you remember, the size of operator gives only integer value because all the data types have integer number that occupied by it. For example, integer occupies how many bytes? 2, float 4. So let's hear how it can work. So here I am taking simple variable integer A and A equals nothing but our operator, that is size of. inside size of you can pass two things, variable or a data type. Right now I am taking just data type, that is integer, and print that value of a. So printf, inside printf we have to write a equals nothing but %d and the value of a. Now what is the output of it? A equals 2, obviously. But here my laptop has a 64-bit processor. So instead of 2, now it gives the answer 4. So that all the size will be depends on a processor. So all the data types and its size that we discussed in our data types theory is just for a 32-bit processor. But it is vary according to the different processors. Clear? So here you are getting not a value 2 but you are getting 4 answer. Let's see here by executing this program. So here a equals what? 4. But if your laptop or desktop have a 32-bit processor, then it gives the answer 2. Instead of data type, if you want variables, then how it is possible? Here you have to write the variable and declare the same variable, that is b. So b is of which type? Integer. Clear? So by obviously the answer is same, just simply I am changed, instead of data type we are putting variable name. So the same answer we are getting. Compile this program and run. That is a equals 4, and instead of integer, suppose you are writing float, then your answer is change. Run this program. So float occupies how many bytes? Again 4. So these all are about the operators. And last I am taking one example for a implicit and explicit conversions, how it works. Now implicit conversion and explicit conversion, if you remember, we will learn one simple example of a division operations, and that we will use in this same program, that is integer a equals 9 and b equals 2, and answer obviously for a division it is in a float. So for that we taking one data type, that is float of c. Now what is the expression for division? C equals nothing but a divided by b, and print that value, printf division equals %f. Why? Our answer is in a float and that we have to print. So %f and then C. Now execute this program. First error is 0 0 and run this program. The output you can see here, that is 4.60. So correct output is what? 4.5, but this is what? Implicit conversion, that is done by the compiler automatically. So we are not finding that particular answer that we want. So in this case we have to change for another method, that is explicit conversion. And the syntax for explicit conversion, or we can say typecasting, is nothing but we have to write in a bracket the data type before the variable or expressions in which you want to convert. So for that, suppose I want to convert our variable a into float, then simply we have to put in a bracket just the data type float. So it becomes now a explicit conversion, and by executing this program we are getting the right output. How? Because a is now converted into float and float divided by integer. So the final answer is in a higher data type, that is float, and that value will be assigned to our C, that is again in a float. So run this program again and find the output, that is division equals 4.5 and then remainings are 0. Clear? So here you can use type conversion, different methods when your logic has requirements. I hope you guys understand this concept very well. We will come back with very different topics If you like this video, then thumbs up. If you think this video will help some of your friends, then do share this video with them. Also, you can subscribe my channel, so when I upload new video, you get a notifications. Thank you. If you have any doubt, feel free, contact me.